Good morning, good afternoon, good evening, everyone. Welcome on Learn Grasshopper live session. We are continuing programming in AEC topic. Today we are going to discuss the topic which language to choose, Python or C#, or maybe even start with Grasshopper. So we combine that with the Q&A session with two amazing guests, Sverre and Marcin. Guys, can you hear me?
Nice and clear.
Yeah, perfect.
Perfect. So maybe you can introduce, Marcin, start. Which team you are supporting? Are you team Python? Are you team C#? Or maybe you're a team of other programming languages?
Well, to be honest, historically, I was starting from C++. But maybe because of that, I am today in the team C#. So because there is something in common with the C++ and the C#, not only the name.
Mm-hmm. And you, Sverre?
I started out with C#, but
really? I didn't know that.
Or first Python in some programming, or MATLAB even in some programming courses at school, and then C#, and then then back to Python again. So now I would say 95% Python, 5% JavaScript ish, maybe 2% C#.
And a question to you, we have already some people waiting. Write down what is your programming level in Grasshopper, in Python, in C#, from scale from 0 to 10. 0 if you never used any of these languages, 10 if you are master as Marcin and Sverre.
5 if you can print "Hello World" in the terminal.
That's a good. That's a good one. It can help. And zero if you think Python is a big snake. So we have a 0 level. So I assume that also you can hear us. If you just maybe you can also let us know if you can hear us and see the screen. But I assume we have already some answers, so I assume that you can hear us pretty well. We will start in just 2 minutes. Please let us know what is your programming level. So we have beginners, Geralt 2, Sunburst 0. All right, so we are starting.
I'm waiting for 10. Maybe I should type 10 then.
So we have lots of beginners here. So that's you guys also, when showing and describing the topic, please consider that, okay? So another 3. All right, we have Alexander for 8 from LinkedIn. Okay, so we are still waiting for 10. Maybe we are not going to start. Just give you, and I'm going just to repeat. So today we are going to present practical examples of using Python and C#. What are the differences between two languages? And at the end, we are also going to share our details about training program, how we are teaching all the 3 languages, Grasshopper, Python, and C#. Sky Infra Consult number 5. All right, so basically if I'm going to take the average, so the average will be 2, 3 in my opinion. So guys, remember about that. Jorge, hello everyone. Arturas 3,5. I'm really interested. What does it mean 3,5? Maybe Arturas, if you can just write more. I'm really curious. What does it mean 3.5? All right. Please, for those who are jumping in, please write your programming language. It will really help us to adjust the content that we are going to present. 3 and 5 as well. 3.51. Okay, so we have better and better answers. All right, let's start right away. So we are live. We are live on Facebook. We are live on LinkedIn and YouTube. Today's session, I think it will be around 90 minutes. We try to keep it as a maximum. We are going to present Python, then C#. I'm going to present details about our programming in AAC learning platform, and then we'll have Q&A session. Recording will be available, but just couple of days afterwards, it will land in our archive in the YouTube. And as always, ask and write questions. We are here to support you, and I'm always checking what is on the chat. So if you will have any questions about programming languages, which we are going to present examples, and if you would like to that we can explain more in depth, so please let us know in the comments. So today we are going to present real engineering examples with both languages, and we're going to show what are the differences, and we'll give you also the step-by-step process how to start with the languages. So today's presentation is Python or C# clear practical examples. And in the left corner, we have Marcin, and we had this battle, Python and C#. I don't know, Marcin, if you remember, you said when we had this battle between these two programming languages in AEC, you said that C# is going to beat Python in technical knockout in 3 rounds. So Marcin is going to be responsible for the C#. In the right corner, we have Sverre. Sverre, as he already presented himself, he is using 95% Python today. Yeah, so he really strong up to all the Python community and all the libraries, especially that you can use these libraries in Rhino 8. For those who are seeing me for the first time, my name is Wojslaw, and I'm going to be referee on this Python versus C#. I'm a bridge designer. Now I'm 100% focused on teaching engineers how to transform their work with programming to have more fun and to become computational designers. So just to start comparison really quick, Python, it's much older. It was developed in 1991. We have tens of millions more users than C#. Strong sides of Python, there are readability, and the weakness is performance. But actually, it's not that bad if you know what you are doing. On the another side, on the left corner, we have C#, much more younger, developed by Microsoft, and strong sides. I think Marcin is going to talk about that several times, going to underline that performance is one of the best, strongest sides of C#. The weaknesses is the steep learning curve. And for sure, we are going to discuss that. We had this whole battle couple of webinars before. So we had 11 rounds, and we compare, as you can see, syntax, AEC APIs, communities, web applications, softwares, machine learning, and so on. You can get this whole recording here on learngrasshopper.com/Python versus C#. I'm going to also copy that link in the chat. You can scan the code. But today, we are not going to focus on just comparing. We are going to share more examples what is possible to do with the languages. So maybe we will start with Python. So let's start with Sverre. I'm going to hide myself and Marcin. So Sverre, the floor is yours. So tell us what we can use Python in practical in the architecture, engineering, and construction related topics.
Yeah, thank you. No pressure. So thank you all for coming, first of all, and for listening to us. I'm really humbled by being able to be here once more and sharing some of the stuff I really love to do. And I will try to briefly now introduce you a little bit to Python, assuming you know, starting from 0 or maybe 1, just know that it is a programming language. And I also assume that you know what Grasshopper is. And first of all, just why should we bother learning programming at all? And just the main reason for me is that we're one of the most inefficient industries in the world. If you compare kind of the amount of energy we put in compared to the output that we produce. So there's definitely some room for performing better there. And the biggest motivation for me, at least, is to automate the boring stuff. So every task that we do multiple times every day, that we keep thinking, there must be a better way of doing this. That's where we should start to think about programming. And programming is also a great way to connect data across software, so you can bridge different software using programming and also tailor the software to your needs. I will try to show some examples of what I mean by that. But instead of buying expensive add-ons from proprietary vendors, we can actually, with some minor programming skills, solve the problems in-house or by ourselves. And then why should we learn Python? And why is that, in my opinion, of course, the best software or structural programming language to start with? And the 3 main reasons for this is that it's very easy to learn. It has a straightforward, readable syntax and a lot of ways to write and run code without having to download a specific software, run it through an IDE. You can use it inside Grasshopper, of course. You can use it inside Dynamo without installation. Any other installations, you can use what is called notebooks, which you can access online. Or, of course, you can just install Python on your computer and use whatever development environment you want to use. But there are multiple ways, and you can go from integrated components in Grasshopper to fully fledged kind of software engineer style development environments. And you can do that, of course, gradually. Also, they have a huge open source community. There are a lot of resources for getting help, asking from the very basic questions to nitty-gritty details of specific packages or details. There's always someone able to help you. And there is also, and especially for the AEC industry, a rich ecosystem. And what do I mean by that? There are, or most of the software that we use, or at least that I use, has some sort of integration with Python, meaning that I can work with the software from Python. I can write data to it, I can read data from it, I can most of the time modify some data within the software, meaning that Python works for me as kind of a Swiss Army knife between different software. So be it that I want to read the results from a structural analysis file and enrich an IFC file with it, or just export it to an Excel file for a colleague, Python comes to the rescue there, saving me a lot of these repetitive tasks. And finally, I think the beginner friendliness of this is specifically interesting for us as engineers, because first of all, we're experts within our domain, so social engineering, architecture, whatever. We're not data scientists, and most of us don't have time to get into the theory of data science, so Python is perfect for that as well. And trying to show you some examples, I want to start within a familiar environment, Grasshopper, with the package or module IFC OpenShell, which is an open source, community-driven and developed, free-to-use Python module that you can install also within the CPython component in Grasshopper, allowing you to modify, read, write, edit IFC files. And one way this has saved me a lot of trouble and also some expensive software, especially for very simple use cases, is the pain of importing an IFC model into Rhino, for instance. If you just want to view it, I'm going to do something else in my Rhino file. I just want an IFC file from some others to see the environments of which I'm working in without having to export my own geometry to Solibri or another IFC file and view it there. I want to have it live inside Rhino. And this example shows how easy it is with a couple of lines of code. No external software is needed, just writing a Python script that allows me to create some native geometry, some meshes, Rhino's mesh class from the IFC file. So here you see the code. I have some input. I have the file path. I name some, I can zoom in a little bit. I name some classes that I'm interested in, what I want to show. Maybe I want to check that my geometry structural model, finite element model, matches the architect's architectural model of the building, for instance, and also have a run button. And that's all I need, together with some code, in order to run and import the design. So if you see here, I just close it, I run it. This is a very small IFC model, so of course it's very fast. It's one of the free demo models that you can find from IFC OpenShell. But it just shows that this is a really simple way of getting started with tailoring your needs to your software using Python. Another thing that Python excels at is data analysis and reporting. Say that you have some data on a tabular format and you want the classic create some nice reports, plots of that. Python can do that really easily. Again, I will show you in what's called a notebook. You can do that online. You can check out Google Colab, Jupyter notebooks, whatever. Don't need to install anything on your computer. Upload your CSV file, Excel file, and in a couple of lines of code, you go from tabular data to beautiful plots. So I'll show you a small example of that as well. And this is a notebook. So this is also a great way of combining code with text for reporting and documentation. So the text you see here is called Markdown, which is just a very simple, say, code for writing text. And you can have what is called code cells here. So I write some text, and then Markdown cell where I write some text, and then I have a code cell where I do a couple of lines of code, and then I can just run that specific cell, see the input. So here I import the data set, so a CSV file or just some data, and I just show it. So I just visualize it to see what I'm actually working with, just an excerpt of that, the 5 first rows in this case. I can then, in a couple of lines of code, just visualize the data set. As you see here, I say which axis I want, and I just print it. And then you can change the style, you can change what kind of data you want, what kind of plot you want. And this library is called Seaborn, which is one of those open source modules that you can just import on top of your Python installation. And then you have a lot of these beautiful plots at your hand in a couple of lines. Another example is to use machine learning with Python, again, using libraries that are very easy to download. In this case, it's TensorFlow, but you have different languages as well, such as Scikit and PyTorch. And with TensorFlow here, I'm just creating, again, a small notebook where I'm doing the classic MNIST dataset. So everyone who's seen a little bit of neural networks, machine learning, have seen this kind of benchmark example. So it's a set of handwritten numbers, compressed as images that you want to train a machine learning algorithm to predict which number it is based on these images. So we can do that here using the Keras engine and TensorFlow, which is kind of a high-level wrapper for a lot of those nitty-gritty details that I'm no expert on. But I create a neural network. I specify the number of layers that I want to create. Oh, sorry. Very sensitive mouse today. So here you see I build a model. I split the data into a training set and a validation set, and we start training it, and then I can summarize the right and wrongly predicted images. And once you have that model trained, you can save it and you can use it on your own data. So be it a business example, say you want to flag some wrong data that comes in from a pipeline of a whole lot of data to save you the manual labor, for instance. This is one use case of doing some simple machine learning with Python. Another more practical example that I found these kind of machine learning packages to be very useful for is that bridge for me as a structural engineer. When you're almost finished with the design, you're kind of done with the engineering part, and then you just want to choose kind of a good or optimal solution to your design problem, which is also feasible from a practical point of view. So what this notebook does is using a scikit, another library, which I can import, to select or help me choose the best combination of pad foundations, so column foundations, so rectangular or square foundations, based on my input design forces from a finite element analysis. So I have a lot of foundations that needs to be designed underneath a building, for instance. I have the design forces. I can calculate the necessary width and breadth of those foundations, and of course, if you just use the formula straight away, you will probably have as many optimal solutions as you have columns. But in practice, the contractor would never agree to building something like that. So say that he allows me to use 5 different foundations. Which 5 foundations should I then use in order to use the minimum amount of concrete, for instance? And doing that manually would be a lot of pain, a lot of work, checking a lot of combinations, but just importing this into a notebook, importing a clustering algorithm where I give it a lot of different options of sizes, and then helping that choose for me the combination of, say, 5 foundation that returns the minimum amount of concrete needed, so the volume of the foundations. And here you can just see the results of that for different sizes, and you can see that you're kind of covering all the cases here with the necessary dimensions. And another example, again, within a notebook of reporting and communicating is this example using ANSYS. A lot of notebooks here, but I just want to emphasize that you can start out with Python without really needing to download any complex software. So in this case, I did some, or a lot of, maybe 50 different variations of some detailed connections in ANSYS, a finite element software, which is quite complex, quite expensive, so you don't want to spend too much time on it. And they have also a Python API module where I can read my results into Python using the API. Or the module, I can extract the results, I can plot the actual geometry with the results on it, which is quite amazing. And this is also interactive, so you can kind of drag on it, you can zoom in on it, the details, you can summarize it. So instead of me going through 50 of those files in ANSYS, taking snippets, etc., I can just set the camera angle, for instance, I want in my report here, and just rerun this script 50 times, and it gives me everything I need for my report, which again, really effective, automating the boring stuff using Python, open source tools to give me what I need.
Just one thing, Sverre, on the last webinar you showed also Jupyter how to use AI. Can you please tell us more how LLMs models can be used here?
Yeah, are you thinking just creating notebooks in general, or?
Yeah, correct.
Yeah, sure. Maybe I can do it here. Of course, you're not getting away from using AI at some point. This was created actually before we got all of these LLM models, so I probably use like 15% of the time I did once I wrote this. But Of course, you can integrate these with machine learning. So most of those professional softwares now have some AI agent integrated into the tool. So you can just click a button and ask it what you want it to write, and it will write the code for you. It will help you import the data. It will help you format it, etc. And if you're working on your computer, you can use whatever agent you have there to work on your code, because this is just kind of JSON based. So you can actually also work on that behind the scenes, creating these cells and Markdown for you. So integrating this with AI is extremely simple, I would say. There are so many ways to do it, from just typing in the chat and copy pasting the answers to actually having agents working directly in the file for you. But you should always know the basics, of course. And then another thing that you will encounter once you start getting good at programming is that, of course, not everyone else at the office is good at programming. And even though you make amazing scripts with amazing results, if you present it to them as code, they will not trust it, because they don't know how to read it, they don't know how to interpret it, and they probably even don't know how to run it or change variables. So how do you go from your source code to something that makes sense and can be shared with others that doesn't know programming at all? And Python also, of course, has applications and tools for that. For instance, starting a little bit low level, but a library which actually is really cool, I've been using it a lot, is Django. So you can build websites with it, and you start and it's kind of, you create classes for models and forms. So you kind of create SQL models with Python, but you also use HTML to create the website interface. You need to know some HTML. You probably need to know some JavaScript at some points if you want to do something a little bit more advanced and dynamic. But at the bottom there is a really good Python library if you want to check it out. And you also have Victor that we have some bonus materials on in our course, I think, which makes creating apps really easy, not just for Python, but if you have Excel scripts or Grasshopper scripts that you want to share with colleagues without them having to have the software installed, but you can access it from a website, also a very good option. And then you have my favorite at the moment, which is Streamlit. This is an open source, again, Python module. So you install it like any other module that I showed you previously into your Python environment. And then you can start building really cool web apps with pure Python script. It takes care of everything from the styling of the HTML to building of the application for you. You just write pure Python. So I will show you a small example of that as a conclusion to this little excerpt of cool things you can do in Python. So here you see I moved in to a little bit more advanced text-based editor. This is Visual Studio Code, which is my preferred editor for writing Python code. So this is just a basic Python file where I import my libraries. At the top here you can see what I want to achieve here is just to move away from some of those small applications you have at the office, or even an Excel sheet which calculates some basic verifications for you. So in this case, the capacity of a concrete section. I'm just creating a square, simple concrete section with some concrete material as input for the user, some reinforcement, size of the reinforcement, cover, etc. Assuming that it's kind of pure bending, simply supported beam I'm looking at with reinforcement only at the bottom. But you can see here almost 300 lines of code, nothing but Python. And then I can run that in my terminal. I start up the app. And then I have a fully fledged, user-friendly application. So here you see it. I can illustrate my cross-section to the user dynamically. I have an input section, and I have the main output page. So now anyone who doesn't know Python can go in here, work with it, play around, changing the inputs of the script, concrete quality, the width of the cross-section, the cover, the number of bars of reinforcement. You can, of course, add warnings, edge cases, maximum, minimum, allowed, width, height, to keep it kind of feasible physically. and then it will calculate dynamically for you. So here you see the plot of the cross-section is updating live. I get the input parameters, I get the results here, the bending moment, the compression forces, etc., effective depth. And this is using another open source Python code again called structural codes, which helps do a lot of these code checks for concrete. Also open source, which again, what's not to like with this? And I can give the user some meaningful results. So here I just present kind of a roughly integrated moment curvature relationship, the bending curvature diagram, and just the cross-section parameters. But again, 300 lines of code and you have a Python app. And you can host this on Azure, you can host it as a Docker container on whatever you like. You can pay Streamlit to host it on Snowflake. I think that's their business model. They're providing you with an easy way to get this up and running, so you don't pay for the module, you pay for them hosting it for you. But of course, if you have some company solution to keep this as an internal tool, you can also do that. So yeah, I think this is kind of wraps up at the end everything that Python is about for me. Easy to use, a lot of open source communities, and with the ability to share it with your colleagues.
That's a great examples. Thank you very much. If you have any questions to the audience, please let us know. Maybe you have been using already some of the Python. We've seen some level programming 8 and 7. So maybe Jorge, 6, 7, and Alexander, maybe you can also share some examples that you've been using. Please share, because we have lots of beginners who would like to start with programming languages and looking for inspiration. So you, Sverre, said that you started with C#. So what brought you back to Python?
I think mainly all of the examples I just shown now. So when you're in C#, you're kind of locked to, without being too technical, you're kind of locked to the editor on your computer. You have to compile, so you have to build your code before you run it, whereas Python is running you're running it like live. You don't build it or compile it before you build it. So it's a runtime language, which makes it really easy to just, like, whatever computer you're using, you just pop up some Python online, or you have an idea. It's a really good tool for sketching out your ideas, building apps, linking software without having to spend too much time on kind of the software engineering details below. And I think as an engineer, you know, I never have the time to start from scratch every time building a full web application using C# that can be run on Windows. I mean, that's just not feasible. I want to do the structural engineering, but here you see with Streamlit, 300 lines of code. I have an app that I can share with my colleagues. And of course, I'm not an expert on Streamlit, but most of these packages are very goodly documented. So you will find whatever you need to get started. So you know the basics of Python. You're not an expert on Streamlit or structural codes, but you find the documentation online. And of course, with the AI agents, which can read through that documentation, you can create your own MCP servers, even just giving it access to the full GitHub source folder. I mean, there are really endless opportunities for me.
We have some question from Mohammed. You started with presentation with IFC OpenShell, and we have a question. I have created an IFC web viewer, and I would like to connect IFC OpenShell. Is there a way to do it?
You know, I think I've actually seen someone do that with Streamlit. I think you need some JavaScript there, kind of integrating or embedding the viewer into Streamlit, but I definitely think it's possible. But I think then you're at kind of level 9 programming. If you want to do that, it's not 300 lines of code anymore, but it should be possible, yeah.
And yeah, IFC OpenShell, as I said, you started with it, and I think it's a really great topic, especially for all the Beam engineers, that finally you're not limited to the software. So finally, without any additional software, you can explore your IFC even change that. Even the IFC was created in the different software. Do you have any more practical examples of IFC OpenShell, like you using at work?
Yeah, we've been using it to kind of, if you want to enrich your models with some external data without having to kind of go into Revit or Tekla or kind of clicking through it. We just know that whatever, say we have concrete B30, we want to add some EPD on that. You can filter out all elements with that material, add a property set with environmental, like climate gas emissions or URLs to the EPD, whatever you want. You can do that. You can do kind of these checks of your model, sanity checks. Do the elements have all the properties that they should have to satisfy kind of an MMI level or whatever? You can do the filtering there. Again, open source, run it at night. And I think it really makes sense because IFC is supposed to be this open industry standard which everyone can access, right? But then right now you're depending on kind of really expensive software to open and work in it, which doesn't really make much sense. So you deliver the IFC file to a client who doesn't know, who's not in the industry. They don't have a Solibri license, perhaps. And so they have the IFC file, but what do they do with it? Right. So I think IFC OpenShell kind of comes together with the philosophy of IFC very well.
Perfect. Okay, thank you very much, Sverre, for your examples. Let's go to C#. Let's go to the red corner. So thank you, Sverre. We will come back to the Q&A session. And Marcin, you can share your screen. So let's start and talk about your favorite language. You said that Python is going to lose the battle. So yeah, so please share it, your thoughts and practical examples. Why do you think C# is better to learn for engineers?
Yeah, first of all, do you see my screen? Is it okay?
Yes,
right now?
everything we see right now, it's okay.
Yeah. So well, the first thing is that the C#, it's as you were mentioning, a little bit smaller language. So we have a little bit smaller number of the people who can use C# than the Python, and I am not surprised. And I will try to go through the C# example. I prepare it mostly in the Grasshopper, and I will start with the most important thing. If you are thinking about coding in C# and you're thinking about doing it for the AEC, construction, engineering and architecture, then probably you are very interested in the performance. You don't want to wait 20 or 2 hours for presenting some of the geometry or do some operations. So in this matter, the Python, unfortunately, will be much more weaker than the C#. When I was watching what Sverre was presenting, I was thinking that there is a pity because he focused so much on the Python, and I focus in my presentation a lot about the comparing those two. So I am very sorry, but I will not focus only on the C#, but the comparison of those two. So maybe it's not fully even, but it is how it is. So I'm here presenting a very simple code, generally a code which should not be a problem to any programming language, Visual Basic, C#, or Python, whatever you can use. Generally, it's producing or it's calculating the length between the grid of the points and the beginning of the coordination system. So it's just calculating the distance. Those kinds of operations are very simple. On the left side, you see the Python code. On the right side, you see the C# code. The lines of the codes are quite similar, but a lot of people are saying that, well, in Python, it's much easier to code. I completely can agree with that. It's a little bit easier, but the problem still stays the same. So the whole Rhino and the Grasshopper and 99% of the softwares in the AEC sector, it's written in the C#. So if it is written in a specific language, then using this language will always be faster because you don't have to compile the code. In the Python, you always have overhead. So even if you are using effector 3D from the import Rhino as RG, then it means that you have to read it, create it in the C#, save it, and calculate it. So that's why you see quite significant difference in the time. But here, a small thing. This time it's a time of presenting in the canvas, so you can if you are not super familiar with the Grasshopper, then generally this is the time of the algorithm to run, all algorithm with the reading the input and also writing the output. So it's not really calculating the whole difference between the C# and the Python. So if you have a geometry and you want to operate on the geometry, which is heavier than calculating the distance, then probably we will have even a bigger difference in calculating and operating on operations of the geometry. So right now I create a simple script. This script is generally creating spheres with specific radius. It's really not significant. As significant is that we are creating a BREP, boundary representation, so a sphere, a quite sophisticated geometry. You have to preview it in the Rhino, and generally the code is working in a similar way. We have a grid of points, and here to compare the time, I was using a stopwatch to calculate in the milliseconds only the operation done in the C# without creating the input and the output. So we see that for 10 elements, we have 0.018 milliseconds. In Python, I was using something like a start time and end time, and I was calculating the time in between. And you see that even for the smaller number of the operations, like when we are doing only few loops, here we was creating 10 by 10, so 100 elements, the time for the Python was faster. But then when you increase the number of the elements, significantly you see that the C# demands still quite a small amount of the time when the Python starts to grow, and it's really not growing, but it's sponging, I would say. So with 100, so 1000 by 1000, so 1000 points, we see that generally this change, it's really drastically growing. I think the final one was 500 by 500, so it is around 25,000, sorry, 250,000. And then you see that in milliseconds, C# was creating this whole bunch of the spheres in 13 milliseconds, and 1,400 was for Python. So the change of the time computing and creating geometry with Python and the C# with those kind of the components in Rhino and Grasshopper, it's kind of the significance. You can save a lot of time and computational power. So this is one thing, the performance. The other thing is the clarity. And here, yeah, sorry, it moves a little bit, but the creating of the methods and creating of the loops. Generally, I try to mark how it is to create the loop in the Python, how it is to create the method in the C# and exactly the same in the loop. Well, a lot of people say that in Python, since you don't need to use those curly brackets, then the code is cleaner. And I can agree, it's maybe shorter, but definitely not cleaner, in the sense that using those curly brackets for the longer code can really save the time to read it. And also one very important thing is the difference between typing strong versus dynamic. So why this is important? So generally in Python, it's famous because, like, if you are creating a list or a dictionary, here I am creating a dictionary. Generally, you can use whatever types of the elements as you want. In C#, you always have to specify it is integers or doubles, and a lot of people which are on the beginning not familiar with it, well, they are saying this is a pain and kind of the problem to learn the language. But think about it from the different perspective. If you are specifying it on the beginning, it's already some kind of the comment to the people who will be using this code or they want to modify it. And also, it's not forgiving errors. So for example, if I have a list of objects and I have a price of it, and I will change one of the price, which should be a number, to the text, well, then the Python will still work and it will proceed. The C# code will not proceed. And you can say, well, this is because the Python is not flexible enough. And I am saying, no, it's because it's the C#. You have to really be careful about what you are doing. So actually, if you're creating an error, it will not go to the next and next stage. So whenever you are thinking about the strong and dynamic typing, think about the errors which you can create or you cannot create in both languages. So a similar thing we can observe in the classes. Well, if you are going into the coding and you are thinking about programming, then the classes, it's like the recipe to create some kind of the objects. So making them in a specific way with all of those strong typing that you have to say that it is a string, it is a double, it is a point, it is a line. It's always some kind of the information. In Python, even if you are creating those kinds of the code, especially if think about the code which have 200 lines of the code. If you are not doing those information, what kind of the data type it is, then you have to create a comment. Because if somebody else will be using this code, then probably you will have a call from him every 20 seconds or even faster. So when it comes to the comparison of the Python classes and the C# classes, when it comes to the safety of creating those classes, I think C# is definitely winning. When it comes to the debugging, and I'm talking purely about the Rhino and Grasshopper, then the C# is also winning because it's very, it's the whole Rhino and the Grasshopper is generally written in the C#. So you can use all those suggestions, which I will be talking in a second about. When it comes to the performance, probably I already somehow convinced you that it's uncomparable. Then the structure of the classes, in my opinion, it's a little bit cleaner, but of course, people can have different opinions. But if you will be using a Python and you want to make this code exchangeable with the other teams, with the other people in the team, you definitely need to create a lot of comments. Well, the classes for most of the people in the languages like C#, with C++, C, those with the strong typing, very often those classes doesn't demand a lot of comments. One very important thing is also the Grasshopper scaling, which I will be talking on the last slide. When it comes to the prototyping speed, I definitely can agree that Python is a little bit faster, but it's not impossible to do with the C#. So in my opinion, what is the difference with the C# and Python, especially through the classes? It's a little bit looking like this. Just a small case. This is how I'm creating a new class in the C#. So here you can clearly see that first of all, the compiler or the script editor, sorry, in the C#, it's helping me doing those kind of the coding. But the second thing is that together with the definition of all of the properties and the methods in the C#, we get all other properties of this class. So it's very clean structure when you are coding. Well, if you will go into the Python, because this is a Python, the script editor in Grasshopper will not be so helpful. And I will just go to the IntelliSense definition. So why it's helpful and not, it's called IntelliSense. So in the script editor, even if you will set up that the X is a curve in C# script, if you will just type X dot, you will have all of the methods, which probably if you are at least basically familiar with the Grasshopper, you can recognize, like divide by count, divide by length. So you can divide this curve easily. If you will go into the Python, if you are putting a dot, well, that's a pretty set view. You see generally almost nothing. It's really on one side, maybe it's much faster with coding with Python. On the other side, you are missing a lot of hints from the compiler and the script editor. When it comes to the scaling, well, definitely, if you are here and you want to listen about the programming, and we are here strongly connected with the Rhino and Grasshopper environment, this is how the basic plugin looks like in Visual Studio, created as the standalone plugin, which you can share with the other people. You generally see that all of those things are written in the C#. Adding an icons, creating inputs, outputs, everything is in the C# because the Rhino and Grasshopper is written in the C#. So, well, then the plugin generally looks like this, but it's exactly the same when it comes to the, for example, Karamba or anything else. And that's exactly what does it mean, scalability. Scalability of the C#, it's almost one-to-one when it comes to the creating a plugin or even a software. So if you are thinking that, okay, in the long run, I would like to create some kind of the plugin for the Rhino, for the Grasshopper, like Karamba, like, let's say, Ladybug, then definitely C#, it will be, as you can see on the GitHub repository of the Karamba 3D. By the way, if you are not familiar with it, then you should check it. The Karamba, it's released some years ago, the GitHub repository, so you can just clone it, that you can change the Karamba, you can modify it and adjust it to your needs. So mostly, or 100% of the Karamba, it's written in the C#, or maybe not 100, because the whole core about the finite element method, it's done in the C++, I believe. So if you will click on this repository, you will start to check the files. If you are familiar with the C#, you will very quickly recognize the part of the codes and how to use them. Well, just to mention other softwares. So probably you are familiar what the Dynamo is, Autodesk Dynamo for the Revit, but also the whole Revit is written in the C#. So if you are thinking about creating a plugin for those two softwares, as well, C# will help you. So it is quite popular, especially for the plugins for the desktop, because most of the systems are written for the Windows. And as was mentioned, Microsoft is the creator of the C#. So, but even the tools like Speckle, they are using, and they have been using C# quite a lot to create the connectors, to create all of this interface, user interface. So if you're thinking about a very strong programming language when it comes to the performance, then definitely C# it's a quite good direction. Well, I think that's all when it comes to the presentation. So I don't know if I was too fast.
Yeah. No, it's okay. Like in the boxing ring, we have two different tactics, and Sverre was presenting advantages of Python. Like Marcin went to the direction and just showing the weakness points of Python. It's working as well. I think it's worth to showing. I think in my opinion, the biggest advantage of C# is the integrating C# with most of the software in AEC. Sverre showed also diagram, but actually like the most used softwares in AEC softwares like Tekla, like Revit, like finite element softwares are mostly can connect with C#. And maybe you can say few words. If you know C# and you are using, for example, finite element software like FemDesign, what can you do with C#? Maybe you have some examples from your work working as a senior structure engineer. What you can do?
Yeah, first of all, you can generally create your own or algorithms which are running the engine of the FemDesign. I think 2 years or maybe 1.5 years ago, the FEM Design TrueSoft has opened this opportunity to run the FEM Design in the loop with the C# coding, so you can really create a quite nice optimizations of the calculations. But we should not forget that also robot, for example, from Autodesk, it's also written in the C#, and doing the plugins for the robot, it's also possible. Most of the softwares, in fact, I would say, okay, Abacus and ANSYS, the core of it, it's still written in the Fortran, and they are not changing it for the long years. But most of the desktop application for our industry, for the construction, it's mostly pure C#. So exactly on the screen you see that those kinds of the softwares are, for most of them, even legally, because I'm not saying that you can hack the software, but legally you can create quite nice plugins, and people are opening those possibilities. So, for example, when I was showing you a second ago the picture of the web page from the Revit, then they are opening this possibility to create it. Also, the Rhino Insight, it's also written in the C#. So, if you would like to connect the Rhino with the Revit with the Rhino Insight, this is also completely possible with the C# coding.
And we have a good question from Leo. Can I comfortably write a Python code and let Claude translate to C#? Would it be comfortable to write and fast to execute?
Well, it's working both ways.
Sounds like a shortcut, but
yes, sounds like a shortcut. And I will tell you like this: if you have 20 lines of the code, maybe 100 lines of the code, definitely you can do it. If you will go into the classes, into creating your own components, unfortunately, it will not be so easy. It's opening the Pandora box. It will be a lot of mistakes. But for the basic codes, yeah, definitely you can do it like this. And as I am saying, it's working in two directions. You can write it in C# and it will definitely be translated into Python. And just if you didn't catch it, since I was saying that the Python, it's not the language of the Rhino and Grasshopper. So if you are typing in Python, it is always translated into the C# after all. That's why it's slower, because it's always have to, if you don't use the types of the objects, well, somebody has to figure it out what kind of the type of the object it is. So you are pushing the compiler to recognize, okay, what this type of the object it is in reality. So it is possible. Of course, it is possible. But
we have comment from Alexander. I would be careful about letting Claude translating Python to C# and vice versa. Business logic, yes, probably. Infrastructure, no way.
Yeah. So if you have a small codes, you can do it. So Alexander, it's not my alter ego. I am not typing in the comments meanwhile. so I definitely agree. Of course, the cloud, the AI engines are better and better, and I cannot say that maybe in 1 year from now it will be possible. But as I'm coding every day almost, and I'm also doing those tricks, and I see a lot of my students doing those tricks, and they never are 100% successful with the bigger codes. So.
Okay, thank you. We will answer the last question in the Q&A session. Thank you, Marcin, very much. Now I will take just a couple of minutes and present our programming platform that we opened. Just few days ago, we had the third edition. We opened the third edition of programming in AEC. And what is programming in AEC? We are helping engineers to become limitless, to become engineers for zero. So we started recruitment and registration to our learning platform. So you are going to be ready for the AI revolution in engineering. So learning coding basics to make AI tools works for you. As we discussed today and at the last webinar, we see huge potential of AI, but still foundation of coding and understanding the input and output, it will be still crucial. So with our learning, on our learning platform, we teach you all the programming basics. Second thing, we'll teach you how to automate all the manual tasks in your projects, how to create your own tools, as guys today presented, how you can use Python or C# for different tasks, and how you can make your work more enjoyable. And third, learning programming as an engineer or architect working with construction, you can start a new exciting career path as a computational designer. That means you can get better job offers and stand out in the AEC industry. So we are created 3 trainings. I'm created Grasshopper fundamentals. Marcin created C# in AEC fundamentals, and Sverre, who presented Python, he created Python in AEC fundamentals. These 3 trainings looks like this. I will present in the full picture. So what this training is about and how is it structured? So first of all, it's a self-paced online training. So you are getting login and password. So you can start whenever you have time, and everything is structured on the practical knowledge. So we are 3 of us are engineers, and we created this training for engineers. So you can find buildings examples, stadiums, roads, retaining walls, terrains, bridges, and so on. And is made by trainers that are working with the engineering and construction and also have experience on learning at the university level. We have gathered already more than 3,600 AEC professionals on our learning platform. And what we like to underline is that we are, and highlight, we are teaching the method learn by doing. And I can just show you this example of video. That we are really showing really practical ways. So every single training is based, exercises is based in Grasshopper. So you have to solve the exercise. Then the Grasshopper will tell you if you solve it correctly or not. So you are getting points, getting new scores, and you have to unlock your next passwords. So actually, it's a kind of gamification to motivate our students, and we really recommend this way of working. And we created that for Grasshopper fundamentals, for Python and C#. We are teaching also computational methods for pattern recognition. So you are not just learning languages, but you are also learning how to use that in practice. So when the training starts, so actually, if you would like to join, the platform is already open. All lessons and all modules are available right now. You don't have to wait. And for all the free trainings, we are giving lifetime access to the training and all the updates. So all the free training contains 60 hours of video lessons. We have more than 500 practical exercises for free trainings. We have homeworks, we have closed Discord forum when you can get support, and we have full of bonuses. Every single edition we add new bonuses. So for example, after learning Python and C#, you can learn how to access Revit API, for example, with Python or with C# Tekla Open API. After modules about environment in Grasshopper. We have also intro to Visual Studio, and we are going into more advanced stuff, and we are showing how to build your own plugins. Sverre mentioned about building apps. We have lessons about building apps with Victor and Python, and we are also including that. Rhino 8 came with the new script editor, and we also added new lessons how to use Python, CPython, Python 3 inside Rhino, and we made updates for that. Documentation in Jupyter, how to make all the documentation, how to make the calculation, how to include the images from your reports, and how to generate complete calculation reports. We have also access to Karamba API, and we are showing from the engineer structure perspective how to create your own plugins and how to create your own designs. Marcin has also added some lesson about how to use C# in Speckle. It's a really great platform for AEC software. In the Grasshopper fundamentals, we are also have some lessons about AI, how to use it with Grasshopper, how to use it also for writing Python or C# script. And one of the last module lessons, we have the whole module, how to turn Rhino into Beam machine. So we are showing actually how to import and export IFC files and how to manage and edit them. So there is one important thing that joining our program, you have there is zero risk. Your satisfaction is most important. So if you, after 30 days, if you decide that you don't enjoy this training program, you can get 100% money back without giving any condition. And it's serious. Your satisfaction is the most important. Normally, this training is priced, free trainings are priced for almost €3,000, but this time we have the sale, and you can buy this training for free payments for €299 or make a one payment of €197. So if we calculate this price of the days of studying, so it's just €5 per day. So you can see that it's not that much for the time spent with the top experts. And this offer is only valid only 2 days, exactly 2 days, until Thursday, 26th of March. So we are still having registration for 2 more days. If you still haven't decided which training to choose, Python, C#, if you should learn Grasshopper or not, we really recommend to go to programminginAEC.com website, where we have find quiz, and with answering just a couple of questions, what are your software that you are using, what would you like to use programming, so you can get an answer. And we have different packages. You can join Grasshopper plus Python, you can join Grasshopper plus C#, or if you already know Grasshopper, so for example, you can just join C# and Python. So to sum up, we are opening the doors for programming in AEC program. So it's a self-paced online training with the lifetime access. It's really important. So whatever new updates will come in the next edition, you are going to get these updates. Everything is based on the practical engineering examples, and there is zero risk joining. We have 30 days, 100% refund policy. More information can be found on programming in AEC. And I will check the comments, and we will come back with Marcin and Sverre. just before Q&A session, if you have any question regarding the presented materials about Python and C# about the training, now it's the time that we are going to answer your question. I'm going to go through the question that I missed during the webinar, and we are going to answer that. So Marcin and Sverre, nice, you are back. So let's back to some question that we had, and we will have still some around 25 minutes that we are for you. So let's come back. Sergey said that, Marcin, you mentioned Ladybug. If I remember correctly, it was written in Python.
Yeah, you correctly remember. It is written in Python. I make a mistake. I was thinking about a little bit different plugin. I was thinking about the one for the IFC, the visual arc. But when it comes to the Ladybug, it is true. It's written in the Python, but it is the core of the Ladybug. In fact, it's written in the C++. Because it's using open foam system, for example, for the butterfly and so on. So we have been coding quite a lot of things with the Ladybug, obviously, because it's the sunlight analysis and all of those wind analysis are quite popular in our sector. So yeah, you have right. It is written in general in Python.
Arturas wrote, to sum up your presentation, guys, the Python is suited for data analysis and C# for integration and API. Sverre, is this too much simplification? And would you agree?
I think it's a little bit oversimplified. Yeah, I think as soon as you want to build something that's kind of robust and as a standalone application, definitely go into C#. But it's a lot of things you can do with APIs in Python as well. And I think some of the examples from the C# Python comparison kind of oversimplify things a little bit. So the IntelliSense, for instance, that's working perfectly fine. You just need to use type hints, kind of telling Python what it is. So if you say this is a curve, you can do that in functions, classes. Of course, it doesn't solve the problem of compile time. So when you compile it at runtime with Python, it will ignore them. But for the readability and for the IntelliSense to work, it's a great tool. And also the performance, there are things you can do in Python as well to speed that up significantly, not using kind of for loops, which is the slowest part. But again, the API integration depends on what you want. If you just want to do something kind of to start out, this is not something that your company depends on as a plugin, Python is perfectly fine. But if you do software development, then you'd probably do C#. If you don't do software development, and that's why I'm using Python all the way, because I'm not doing software development. So I think that's my summary of it.
Marcin, the next question will be for you. Since C# is highly performant, what are the things it can do as well as Python?
Well, it's plenty of the things. Well, all of the AI.
The floor is yours.
Because the C# can do as well as Python, definitely, you know, all the TensorFlow, all of the stuff which has been created in the last years to the artificial intelligence, machine learning, deep learning, and so on. Those are mostly, per definition, the Python environment. And I will not, you know, the situation right now is that I'm trying to promote the C# a little bit more than the Python, but in reality is if you are working with prototyping of some kind of the solution, or you want to test something, then as Sverre was saying, there is first of all much more people working with the Python, much more of the small projects are developed with the Python. So if you are not really dedicated into creating your own plugin, which is closed, and you want to, for example, sell it or distribute it along the big company, then probably Python for your usage will be kind of the preferable solution. Definitely AI, it's something which I cannot do with the C#, or I can do it with, for example, Microsoft tools, but they are not so good as the other stuff like PyTorch, TensorFlow, and stuff like that.
Cool. Let's stay with C# and Marcin. I know that you've been working with Revit. Are there workarounds to speed up the runtime on the Revit thread?
No, I am not a fan of the Revit, so please don't, because I don't want to blackmail anybody here. I try to be positive. I can work with the Revit, but as I see some kind of the workaround to not work in the Revit, I am doing it. But
no worries, I do not have any agreement with Autodesk. Autodesk is not sponsoring me, so don't worry about that.
Yeah, so I'm very skeptic about the Revit and the whole concept of developing the software. I was very positive when it was going into the market, and I was, I think, one of the. I was quite young when it was showing up in the market, and I was using it quite a lot for many projects. But I think it is stagnant. For many years, it is not developing at all, and all the spreading and the speed of this. It's just making it impossible in, for example, my profession, especially when I'm working with the concepts of the designs. It's so slow. So sorry, but I don't think there is any.
So what your method is to avoid Revit?
Yeah, of course I'm using Rhino, Grasshopper coding, hard coding, creating a lot of stuff, and then when I see that this model is good enough, then I am sending it to the Revit, to somebody to just rotate the building and say, this is the beam model.
Alexander said that I agree Revit has terrible support for it, but as long as everything happens synchronously in the main Revit thread, you should be able to do everything else as async, I think.
Yeah.
So I think Alexander, which is also quite experienced, I think there is no such a method. Sverre, could you please share the concrete beam example code? Is it something that you can share, or?
Yes, I think I can. Yeah, I will clean it up a little bit, and yeah, I can. I think I can share that. Yeah.
Yeah, that's cool. Wouldn't mastering Python be quicker after learning C#? Could we draw such an inference?
Yeah, I think the first programming language would probably be the one to spend the most time on learning, kind of regardless. So, because after that it's mostly syntax and logic. Once you know the basic logic behind it, I think it's easier to learn another language. You kind of see what's going on. You see the things behind it. So yeah, I would say so.
I think it's the same with learning foreign language. For me, it was easier after I knew some German and English, and learning Norwegian, it was kind of easier. So yeah, I can compare that you know some logics that you can and reuse from other languages, speak languages. So I think this is definitely should be easier language after language. Okay, so we have good comment here, more for debate. And we have Marcin and Sverre, who work for engineering companies. So the question is, perhaps not the correct forum for this, but one of the biggest challenges with both programming languages in AEC business is to get the necessary resources allocated by your company to actually develop and required tool in the first place. What are your experience with this. It's a broad topic. Sverre, maybe you could start, because I know that in your company you are developing a lot of tools. You are more than 50% on developing, or
No, I don't think
not that much. Not that much.
not that much. Can you put up the comment again? I want to read it. I didn't get a chance to read it. I think I definitely see Alexander's point, and I share it to a large degree, or to a full degree. I think, what should I say? It's hard when when you're paid for producing per hour. Like the business model in our industry is normally paying, you're getting paid per hour, and then you have kind of an incentive perhaps to why should we automate if the contract is paying you to be slow or use the time you actually spend. So I think it's also a mindset that we need to change, if that makes sense. Where is the incentive of developing a tool? Also for our leaders, why should they allow us to do that when they are measured on like the billability or how much we're billing the customer per week, instead of us saying, okay, but if we bill him or if we bill him what we should do, and then we spend some more time in this project to actually develop the tool that makes us do the same task twice as fast the next time. Where do we make that money? Do we kind of do it for fixed price and then spend the time we spare every project to keep developing? Or I mean, for me, it doesn't add up at the moment. So you end up, I think, a lot of the people who actually develop these tools are doing it because they're really passionate about it, and they do it not because they see and they like making the company any value, but they just really want to make things more effective. And I think we need to rethink on a larger scale how we actually sell and acquire and how to say manage these tools that we should be creating. I think that's what I can say.
I think like Mohammed was from his comment. I can also show it. From what I have seen, the bottleneck isn't the resources, it's the people. Out of 100, maybe 2 or 3 can actually handle computational design properly. I guess it's one of those things, not exactly built for everyone. Marcin, do you have any thoughts on that?
Well, on the whole topic, I could spend an hour or two talking. So I generally agree with Sverre. The whole system which we have right now in the AEC, it's somehow not really pushing the automation and the computational design forward. So I think we have some systematic issue, or I would say a problem with the mindset, as Sverre is saying. We are spending, because I generally agree, the resources are not enough, because, and also the resources are not put in the specific place. In the hour-based salary, it's very hard to demand from anybody, from the engineers, if they don't know the tools good enough, they don't have enough good programming skills to work after the work and to develop the codes which will automate maybe in the future something which they are spending 100 hours right now. Also, I am in this market for around 20 years, and I'm constantly fighting for some kind of the really leveling up the automation in the design, in the creating drawings, in creating calculation. I think me and Sverre have this privilege that we were doing a PhD. We have time to really level up our skills to the level which is allowing us to do stuff which for many people would be really not achievable in the normal system when you are working 8 hours and then you have to spend something extra. So also because of that, that one of the reasons why we are here is to create a course which is allowing engineers like we to really develop the skills to try to change this whole system, because I believe Sverre has the similar thing that very often we are doing stuff in the old way just because our boss knows the old way style of doing stuff. And we want to teach people because we want to push this whole system to work in a little bit more different way, in a little bit more creative way. Because very often right now, we are spending the engineering stage of the design just to produce some calculations, to not discuss this calculation, but to produce them. And I think if we will automate a lot of stuff, we will be able to really discuss the options in the design, to discuss which version of the calculation is better, which version of the building is better. So this is my aim. This is also the aim why we start to do these courses, and why I'm still teaching in the university, because I saw that, okay, I can do some computational design in the companies, but after all, I am always finishing the same, extremely exhausted, and well, it's this really the question, what are my experience with that? I would say problematic.
I think we have the whole discussion here under the post, so it's a topic. So maybe this will also, we organize another workshop or webinar about this topic, how to talk with managers, how to that. Because what I'm seeing also from my perspective, that right now is coming from bottom up, like eager, passionate computational designers want to change the world, and afterwards hit the wall that you have to fight with managers. But yeah, let's put a point here, and so this is the broad topic. The best way is to start from your perspective and to learn new ways of automating stuff, and yeah, maybe slowly the industry is going to adapt. We have a few questions that I would like to mention more. It was a question to Sverre. Does your company develop projects or workflows driven by data analysis? I am curious about the industry current adaptation rate of data analysis and machine learning methods, Sverre. Is it something you can share?
No, not what we're actually doing that I can share. But yeah. I mean, I think a large part of handling more data is figuring out how to manage it, extract it, work on it, and make some meaning out of it. So yeah, I would say data analysis is part of it. Maybe not so much structural engineering yet, but on a bigger scale, definitely, yeah.
Sorry for joining a bit late. Could you please confirm whether it's essential to learn Python or C# for Grasshopper, or if we can rely on AI tools to generate the script we needed? So it's hard to, we made this workshop before fight between Python and C#. It took us 2.5 hours. Now we talk also presented some materials, but I will share just one screenshot. So I think like bottom line, best in industry are using both languages. And if you are thinking about which one to start with the language that your colleagues are using. So it's like one of the easiest bottom lines. And you can also go to programminginaac.com website, and you can do the test for yourself. And in the test, you can just click on the softwares that you are using, at your expectation, what you expect from automation and programming in general. And the score will tell you which language is the best for you. But as the best in the industry, as Marcin and Sverre, they are representing their own languages, but the truth is that they are using both. Maybe they are knowing both, maybe not using so daily. Also, can we choose one programming language in general from Grasshopper, or does each language have its own specific use within the program? Maybe Marcin, would you like to add something?
Yeah, I want to add something because there was a question, can we rely on AI tools to generate the script we need? Well, I would definitely, for example, present the vibe coding which we were doing with the AI in the C#, and we are still not yet there to rely on the AI coding, at least for the more complicated stuff. And also, if you are completely newbie and you don't have any programming skills, you should not do it. I am observing it almost every day with the students at the university. It's really a pain. That the students maybe think they know how to code by prompting something in the ChatGPT. After all those codes are really crappy, and most of the students, after doing that, after some while, they are getting back into the basics anyway. So at this stage, as it is right now, 24th of March, I would say no, it's not possible to rely completely on the AI for the coding.
Yeah, it's really great as an assistant, but still, as an assistant, not not replacing your skills. So this is what we are highlighting in every webinar, that still learning coding foundation will be still valid, and I can take responsibility that not only in 2026 but in 2027 and 8, and at least for next 5 years. Maybe it's a bold statement, but in my opinion, it still be required. Grasshopper, or does each language have its own specific use within the program? It's really hard to answer it in one statement. Maybe Marcin, do you have any?
I think I was showing both ways of coding on my video. So I think this is the user who came a little bit late. So probably if he will get back, he will see that we were presenting both ways of coding very shortly, but you will see generally you have two types of the components which you can drag on the Canva in Grasshopper and work with the coding there. So you don't need to install anything more in Grasshopper. You have everything what you need to code with the C# and the Python. And this is also why the Grasshopper is a very good place to start your journey with the coding, with the programming, because you don't need to install any plugins, any libraries. You have everything on place.
Adolf asked previously, please discuss connecting with Tekla Structure Designer to extract model information and results. Marcin, have you ever used Tekla Structure Designer?
Well, I have been, I don't know how it changed because I was using it 4 years ago on Steel project and before for Concrete. I am not a specialist in the Tekla, so I'm a little bit, I think we have a special, in the course, we have a special hour made by very experienced engineer in Tekla, which is...
yeah, but it's for Tekla structure. But here the question is for structure designer. So I can answer that there is a live link, Grasshopper live link, when it comes to Grasshopper and Tekla structure designer. So you can check out the whole plugin. So even with just Grasshopper, you can extract model information results and manage that with only Grasshopper. Tekla structure designer is based on C#. So if you would like to add additional plugins or go beyond what we have in the live link, so you should check also C#. All right. We have really long question, and I don't think it's a question. It's more generated, but it's just written that, let's say that it's a great discussion. And I cannot see that there is a question. There are some statements. Let me see if there's any question. We have just 2 more minutes. If there are any question, we will wait. We'll be happy to answer. We are finishing recruitment in just 2 days. So if you would like to join our learning platform, so go to programming in AEC.com. So you will find there packages, and you can find out the video lessons, exercises. I think it's really awesome to check out. You can download all the exercises, examples for Grasshopper Fundamentals, C# and Python, because they are really formatted in the fun way. It's a gamified way, so you have better motivation to do. It's not just watch tutorial, it's learn by doing. All right, guys, would you like to sum up this workshop? Sverre, you are responsible for Python, so tell like 2 biggest advantages of Python, and later Marcin can also finish that.
First advantage, you will actually learn it. Second advantage, all the plugins you need to make amazing stuff, and of course the web apps for sharing it with your colleagues, because they will not read your code, trust me.
Fair enough. And Marcin, your summary, why students go for C#?
Well, definitely because it's the best suited for the Grasshopper. So if you are interested in the Grasshopper, then the C# probably will give you the biggest the biggest possibilities. But again, I think the most important is for everybody in our business to just start coding, and no matter which language you will choose, it's just about changing the style how we work. So yeah.
And we have, I think, a good summary from Sergey. Passed both courses, never regretted, different topics covered. So the courses complement each other. From my experience, both languages are in use for different purposes, though I'm a C# side, especially if to develop own plugins for Grasshopper or approaching Tekla API. Python is very in use as well. Take both, as I mentioned earlier. So let's say with that comment, thank you, Sergey, for being with us, and thank you for sharing your perspective. That's all. Thank you very much. Thank you, Sverre. Thank you, Marcin, for your time. It was always a pleasure. Do we have time to answer the last question?
Yeah.
So, Sverre, how helpful is Python within Excel? Should we still think about moving out of Excel?
Yes. Get out before it's too late. But I'm not using it too much within Excel. Then I take it out even before I open that code cell. I mean, it was a big hype with Python and Excel a couple of years back. Tested it out, figured out I'd rather just do it in Python. So yeah, get out of Excel.
I will just mention one thing, that Excel is of course a Microsoft, so you can make a plugin in C# to the Excel. So a point for the C# here.
Why should we go out of Excel?
It's horrible to read through. Testing, version controlling. I mean, don't get me started. I have this discussion so many times, but especially, I mean, if you're just making some simple tabs or bars, it's fine. But once we start doing complex calculations, I mean, we have, I've seen like spreadsheets for doing complex calculation that nobody really knows how to run. I mean, try to open, and you click on that little cell, and then at the top you have 5 lines of code doing stuff, referencing 3 different sheets. I mean, at that point, somebody should take it out and write it in code, like Python or C# at some point, way before you reach that. So yeah.
I think we opened
Don't get me started.
Pandora.
Yeah, it's just
We
the
opened
box again.
Pandora box. Still confused, but I will
going to
continue
stay.
with Python. Thanks for the stream. But yeah, and I really feels what Sverre is telling, because I've been working on some project when I've been using Excel spreadsheet for some calculation, and at the end of the project, it looks like a software. Like, I mean it, with the buttons, with all the programming. So in this point, maybe you should think about the change. Like, on the basics level, Excel is great and we are still going to use it. But if you are building your apps in Excel, then it's the point to think about twice. Okay, thank you guys. Thank you. A lot of nice workshop, great discussion. Thank you a lot for clarification about languages. Nice, great topic. Good night, guys. Bye-bye.
Bye.
Yeah. Bye-bye.